Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, first we observe that 1 raised to the power any integer is always 1, so that helps us to simplify a good portion of this. So the first will just be 1 plus 2 raised to the power 3 raised to the power 4 plus 3 raised to the power 4 plus 4. And we can simplify further. We have 1 plus 2 raised to the power 81 plus 81 plus 4. Okay, so next we observe that this is going to be an even number because we have even, and add to odds we get even. And all the options are all the even digits that are possible, the 5 even digits. So what we're going to take next will be mode 5, because each of these digits will be different in mode 5. So that's, we divide by 5 and keep the remainder. For 6 divided by 5, remainder here will be 1, and for 8 the remainder will be 3. So we see that we have different remainders in mode 5. So if we take the remainders in mode 5 as well for this, we can conclude on which of this option is actually correct. And while we are going through all those processes, because of the number 2 raised to the power 81 is just too big, so we need to find a way to handle it. But for the others, they are not really much of a problem. So let's focus on 2 raised to the power 81 and see what is congruent to in mode 5. Okay, so first we're going to make use of Fermat's little theorem, which says that a raised to the power p minus 1 is congruent to 1 mode p, where p is a prime and a, so p is prime, and p doesn't divide a, so that's a is co-prime from p. And in this particular case, we're taking p as 5 and a as 2, so this means that 2 raised to the power 4 we know for sure be congruent to 1 mode 5. And this is good because it's easier to simplify things involving 1. So we want to see how we can apply this to the number 2 raised to the power 81. Okay, so 2 raised to the power 81, we have to see how we can relate it to 2 raised to the power 4. So what we're going to do is 81 is not a multiple of 4, so to use laws of indices properly, we have to separate that a bit to something that is the closest multiple of 4 we can get from that. So we see that 81 is equal to 80 plus 1, which is 20 times 4 plus 1, or 4 times 20 plus 1. So 2 raised to the power 81 is actually 2 raised to the power 4 times 20 plus 1, and this is 2 raised to the power this times 2 raised to the power 1. And so what we're just using here now are laws of indices times 2. Okay, so now we can go ahead with our congruency. So this is congruent to 2 raised to the power 4 raised to the power 20 times this. So from modular arithmetic, we can simplify this number. So this is at the base. We can take it mode 5, which we already know from Fermat's little theorem that this is 1 raised to the power 20. So this is where we're trying to make use of that. And we're just left with number 2 when we multiply it out. So this means that the last digit of the remainder when divided by 5 is 2. Alright, so with this now we have everything we need. We just look for the mode of that in mode 5. So we have n is congruent to 1 plus 2 plus, now 81, which is a third term. If you divide by 5, you get remainder 1. So this is 1 plus the last one, which is 4. So this is congruent to, if we add all this up, we get 8. And 8 is the same as 3 if we are looking at mode 5. So this means that it must be the one congruent to 3, which is actually 8 itself. So we get this option. Alright, if you enjoy, drop a like, and also I'll see you in the next one.